Hey, welcome to 7.1 and 7.2. We're finally going to get into stoichiometry. Here's the warm-up, pause and do the 3 problems, and then check back in. So the first one is to calculate the number of moles in 4.151 grams of aluminum. So we are going to start with 4.151 grams of Al, which is aluminum. Draw your line because you're converting. Because we are in grams of aluminum, we know grams of aluminum will be at the bottom, and I'm going into 1 mole of aluminum. It's going to be 1 because the number at the bottom is straight off of the periodic table, 26.98. That is the molar mass of aluminum. So your grams of aluminum will cancel, leaving you with moles of aluminum. If I'm doing significant figures, 4.151 has 4, so I can write 0.1539 moles of aluminum. Great job. The second one is how many reactants are in the following chemical equation? Carbon reacts with oxygen to form carbon dioxide. Reactants are on the left side of the equation, so there's 2 reactants. And this is one product. You could also call this a synthesis reaction. Now, the last one. Write and balance the following combustion reaction between liquid ethanol, C2H5OH, and oxygen, which oxygen is a diatomic, so it's O2. So, C2H5OH, which is our ethanol, is liquid, burns in oxygen, which is going to be a gas. Combustion reactions will always produce carbon dioxide and water. Always. It's always going to be a fuel burning in oxygen to produce CO2 and H2O. When I balance this equation, I can write out the elements. I have 2 carbon, 1 carbon, 6 hydrogen on one side, 2 on the other, 3 oxygens on the left side, and also 3 on the product side. Now, I'm going to start with the biggest number, which happens to be 6 from hydrogen, and so I'm going to put a 3 in front of the water on the product side so I can get that to match. 3 times 1 from the water will be 3 oxygen plus the 2 from the CO2, leaving me with 5. Now I have to balance those carbons. I'm not going to balance the oxygens yet because oxygen is in too many different compounds. So I'm going to put 2 in front of the CO2 to balance out my carbon. 2 times 2 will be the 4 plus the 3 on the other side with the water leaves 7. And so I have 3 oxygen on my reactant side. How will I get to 7? Well, I notice that 1 oxygen is in my ethanol. I'm not going to touch that. So 3 minus 1 will be 2. 2 from my oxygen by itself. And if I put a 3 in front of it, 3 times 2 is 6, plus that 1 gives us 7. Here is my balanced equation. 1 molecule of propane reacts with 5 molecules of oxygen to give 3 molecules of carbon dioxide and 4 molecules of water. How would this look like as a chemical equation? Well, it look like this. You have 1 molecule of propane, which is going to be a liquid. It's reacting with 5 molecules of oxygen, which is a gas, to give 3 molecules of carbon dioxide, which will be a gas, and 4 molecules of water, which is also a gas. So saying 5 molecules, 1 molecule, well, those numbers are going to be your coefficients of your balanced chemical equation. And if we're reading this, we could also say 1 mole of C3H8 molecules reacts with 5 moles of O2, and it will be producing 3 moles of CO2 and 4 moles of H2O. This is another combustion reaction where we have our fuel, which in this case is propane, burning in air and producing CO2 and H2O. So The bottom question asks, can we also say that 1 gram of propane reacts with potentially 5 grams of O2 to produce 3 grams of CO2 and 4 grams of water? Can we also say that 1 gram of propane reacts with 5 grams of O2 to produce 3 grams of CO2 and 4 grams of water? The answer is no, because each compound has a different molar mass. So we can't really say 1 mole and 1 gram are the same. A mole is the unit that helps us compare all compounds and elements, but grams are just going to be their masses. Here we have 7.2, mole-mole relationships. The aim is to learn how to use a balanced equation to determine relationships between moles of reactants and moles of products. Stoichiometry is the relationship between reactants and other reactants, reactants and products, products and other products. Here we are going to focus on something called the molar ratio. The molar ratio is the coefficients from the balanced chemical equations. Write the complete equation. Remember, the complete equation will have states of matter, and it will also be balanced. So water decomposes to produce hydrogen and oxygen. We know water is H2O. This is probably going to be a liquid. Decomposes, so it's going to break down to produce hydrogen, which is a diatomic and a gas, and oxygen, which is also a diatomic and a gas. So if I'm going to balance this equation, I'm going to put a 2 in front of H2O and a 2 in front of the hydrogen, because this will now give me 4 hydrogens on one side, or on both sides, and 2 oxygens on both sides. Now here we are going to do our first stoichiometric problem. How many moles of oxygen will be produced by the decomposition of 5.8 moles of water? It sounds scary, but we're going to use the balanced equation to figure this out. You're going to start with your 5.8 moles of water. It's very important to include the elements or the compounds that you're talking about, because now we are going to go from one compound to another. Draw your line for dimensional analysis. Since I started with moles of water, I know moles of water will go at the bottom, and I'm being asked how many moles of oxygen are being produced. So I know moles of oxygen are being produced. The biggest question is, what numbers are we going to put here? The numbers for our molar ratio come from the balanced equation. So if we look at H2O, it's 2, and if we look at oxygen, it's just 1. Remember, if there's no number in front of O2 or in front of any compound, it's going to be an invisible 1, so it's 1 mole. Put parentheses around here. Moles of water is at the top, moles of water is at the bottom, so they cancel. And I will now put this into the calculator, and I will get 2.9 moles of O2. This right here, this is your molar ratio. So your molar ratio is from your balanced equation. Molar ratio, that's an R. So here we have propane reacting with air again, producing CO2 and H2O. Calculate the number of moles of oxygen required to react exactly with 4.3 moles of propane. You are going to start with your 4.3 moles of C3H8, because that's from the problem. Draw your line for dimensional analysis. You know that moles of propane will be at the bottom. To figure out what goes at the top, it's asking to calculate the number of moles of oxygen. So I know moles of oxygen will be at the top. We have to use the numbers from the balanced equation to fill in our molar ratio. So it's a 1 in front of propane and a 5 in front of oxygen. My moles of propane will cancel, leaving me with moles of O2. And if I do 4.3 times 5 divided by 1, that's going to be 21.5 moles of O2. So if I had 4.3 moles of propane, I would need exactly 21.5 moles of oxygen to make sure there's nothing left over. Now it's asking, calculate the number of moles of carbon dioxide formed when 4.3 moles of propane reacts with 21.5 moles of oxygen. This isn't going to be one stoichiometric problem, it's actually going to be two. So if I have 4.3 moles of propane, C3H8, draw my line. I know moles of propane will be at the bottom. And this time it's asking moles of carbon dioxide. So I'm going to put moles of CO2 at the top. The numbers that will go in here, the molar ratio, is from the balanced equation. So if there's no number, remember that's a 1. And I'm going to be looking at that 3 from CO2. My moles of propane will cancel, leaving me with moles of CO2. When I do 4.3 times 3 divided by 1, I'm going to get 12.9 moles of CO2. Now I'm going to do the same thing, but with 21.5 moles of O2. Draw my wonderful line. I know moles of O2 will be at the bottom. I'm still calculating the moles of CO2, and we know that the balanced equation, it's going to be 5 at the bottom, 3 at the top. My moles of O2 will cancel, leaving me with moles of CO2. When I put this into the calculator, I can do 21.5 times 3 divided by 5, and it's going to be 12.9 moles of CO2. It's not shocking that the answer is going to be the same because these are our molar ratios from our balanced equation. They did change. However, I know that it's going to take exactly 21.5 moles of O2 to react with 4.3 moles of propane, and I calculated that from the previous problem. So as long as you have a balanced equation, you can set up the molar ratios to figure out how many reactants or products will be produced or needed for any chemical equation using stoichiometry. Good luck with your homework. Send me an email if you have any questions. And again, thank you so much for making it to the end.